Okay, since this is a science class that you're starting out, we're going to have to go over something called the scientific method. You probably already learned the scientific method in middle school, so this should probably be review for you. However, there's a lot of different kinds of scientific methods, but they're all pretty much the same thing. The very first thing you're supposed to do is observe. Make observations. Use your senses and observe the situation. Number two, gather all those observations in some sort of data table. Gather your data. State the hypothesis. Now you guys, of course, have memorized a hypothesis as a what? An educated guess as to what's happening. Well, the great part about a hypothesis is that you can test the hypothesis. Okay? Test to see if you're right. Now, this is where you're going to draw some conclusions. Okay? And I'll tell you right now, 90% of the time your hypothesis is incorrect. So you're going to have to state that in the conclusion and refine. What that means is you're going to have to go back, since your hypothesis is not correct, go back and make a new hypothesis. And then once again test it, come up with some conclusions. Okay, there's a difference, however, between an observation and an inference. An observation is when you use your senses. An inference is based on past experiences. For example, let's say you see something and you say that it looks like a piece of cheese. It smells like a piece of cheese. That would be an observation. Okay, it's yellow. If you said it's cheese, well, that's an inference. Based on your past experience, something that's yellow, something that smells like cheese and looks like cheese, yes, is cheese. But that would be an inference. You don't know that for sure. There's other things out there that smell like cheese and look like cheese. So what is chemistry? That's the name of this course that you're taking right now. Chemistry is the study of matter and its interactions with other matter. But that's a problem. What's the matter? Matter is anything that occupies space and that has mass. Okay. Well, we have something here called the matter map that we're going to go over in just a second, but I want to click right down here. Matter comes in three phases: solids, liquids, and gases. Solids are rigid. They have a fixed volume and a fixed shape. Liquids, however, have definite volume but no definite shape. They take the shape of its container. Gases, on the other hand, have no fixed volume or shape. It takes on the shape and the volume of its container. And gases, one thing that's specific to gases and not liquids and solids, is they're very compressible. I can compress this down to occupy a tiny little volume. Okay? So we have solids, liquids, and gases. Now, if you look down here at very low temperatures, which one of these phases would you expect to have? Typically solids, because at low temperatures the kinetic energy is very low, there's less movement, everything comes together and forms a solid. So this right here from A to B is just a solid. Matter of fact, it's a solid getting warmer because the temperature is going up. Okay? Here we're going to have a liquid getting warmer. So what do you think happened from B to C? If this is a solid and this is a liquid, from B to C, that's called melting. Okay? Notice that from B to C, when you go through melting, that the temperature doesn't change. Okay? You still have the same temperature. Water melts at what temperature? 0. It doesn't melt, well, it does melt at 5, it can melt at 10, but 0 is the temperature at which melting takes place. So then we have a liquid, and it's getting warmer, and then all of a sudden it turns into a gas that's getting warmer. So what do you think happened right here? It went from a liquid to a gas. That's called evaporation or boiling. Okay. Notice that the temperature didn't change again. Water boils at 100 degrees Celsius. All right, so we've got solids getting warmer, liquids getting warmer, and gases getting warmer. Okay, I can take matter and divide it into two parts. Matter that is homogeneous, matter that it's heterogeneous. What does that mean? Well, homogeneous just means to the naked eye you see one thing. Homo meaning one. Okay? Heterogeneous means you see more than one thing. For example, a fruit salad. You see a lot of different pieces of fruit. Okay? If you look at water, you see water. You see one thing. Okay? All right, so we've got homogeneous and heterogeneous. If you take homogeneous, you can divide it into pure substances, things that have pure constant composition, and homogeneous mixtures. I'll get to those in just a second. Pure substances are two things. They're either elements or compounds. Let's start with elements. Elements are any pure substance that cannot be decomposed into simpler substances by chemical or physical means. Now, the smallest representative particle of an element is called an atom. Anything on that periodic table is an element. It says so right there. So, if you have one aluminum in your hand, you have one atom of aluminum. Hydrogen, calcium, copper, silver, these are all examples of elements. Okay? Compounds, however, any pure substance with constant composition that can be broken down by chemical processes. The smallest representative particle of a compound is called a molecule. All right, so if I have one water in my hand, I have one molecule of water. What is water? It's H2O. It's made up of two elements, hydrogen and oxygen. And water can be chemically broken down into hydrogen and oxygen. Okay, so water, sodium chloride, carbon dioxide, hydrochloric acid, these are all compounds. All right, well, what are homogeneous mixtures? Homogeneous mixtures are usually called solutions. There's two parts to a homogeneous mixture or a solution. They're called the solute and the solvent. The solute is dissolved by the solvent to form the solution. It's usually the thing of lesser amount. The solvent dissolves the solute, so it's usually the thing of greater amount. Homogeneous mixtures can be physically separated. I can physically separate salt water back into water and salt. Sugar water. Air is a solution. There's multiple things in air, but when you see air, you see one thing. You see air. But it's made up of nitrogen. It's made up of oxygen. There's some carbon dioxide in there. It's a homogeneous mixture. Everything else is pretty much just heterogeneous. You know, it's pretty obvious to see something that's heterogeneous. However, there are two types of heterogeneous mixtures that people get confused. The two types of heterogeneous mixtures that are commonly confused for homogeneous mixtures are colloids and suspensions. Colloids are all the weird stuff, okay, like Jell-O, toothpaste, hair gel, milk, fog. And a lot of people look at Jell-O and they see one thing, Jell-O, so you would think it's homogeneous, but it's not. It's heterogeneous. There's tiny little gelatin particles that are suspended in here that you can't see with the naked eye, but they are there, and therefore it is heterogeneous. Matter of fact, there's one thing that you can do to test to see if something's a colloid or a suspension. If you shine a flashlight on it and you see a beam of light pass through it, then it is a colloid or a suspension. Okay, if you just have like a saltwater solution, it's not going to do that. But a colloid has all those tiny little particles in there that are going to scatter that light, and you'll actually see the beam of light. This is called the Tyndall effect. Okay, fog. Look at fog right here. You see how you can see the light showing up? Okay, that's because fog itself is a colloid. Suspensions are a little bit more obvious that they're heterogeneous. Okay, it's a mixture with large, more visible particles suspended in a medium. Most suspensions need to be shaken prior to use. For example, orange juice, shake it up. Italian dressing, shake it up. Spray paint. Okay, you see in Italian dressing how everything kind of sinks down to the bottom. You have to shake it before you use it. Okay, that's a good indicator that it is a suspension. So here's the matter map. Homogeneous, heterogeneous. Most things that are heterogeneous are very easy to figure out. Homogeneous, it could be a homogeneous mixture, a compound, or an element.